Okay, on the 8th of April, Throwback Thursday, we had a throwback song earlier of Lovely Day. You guys will be able to find and solve for angle measures of polygons, section 8.2. All right, polygon interior angles theorem. We talked about this last class. We did our little discovery activity of measuring out these different polygons and said, hey, the sum of the measures of the interior angles of a convex n-gon, polygon with n number of sides and angles, is, what was that formula? What was that formula we had? Gauge.
Sum of interior angle measures equal n minus 2 times 180.
Yeah, n minus 2 and that quantity times 180. So that's how we find the sum of any polygon, the sum of the interior angles, okay? As long as it's convex, where it does not cave in, then we can do that. Example 1 here. Let's name this regular polygon. So I'm already being told it's a regular polygon. What's that mean for it to be regular? Actually, let's dissect that a bit. What's it mean for it to be a regular polygon, Kaya? Yeah, it's equilateral and equal angle. So all the sides are the same length as each other, and all the angles are the same measurement as each other as well. Okay. So we're supposed to name this polygon. How could we know what to name this polygon? Count the sides. How many sides are there? 12. So what's it called? It's called a dodecagon, okay? So the name of this is a dodecagon. Okay? And then find x. X is currently just one of the angle measures. How would we find x here? Bill?
Do we have to put convex dodecagon?
On this, if it's regular, we already know it's convex, because regular actually does also include that it's convex. Great question. So because we were told it's regular, we don't need to. Great question, though. It wouldn't hurt to put it, but we don't have to on that. Yep. Aiden. Not the 10, but 12, right? So we put 12 in there, okay? So we're going to do 12 minus 2, which will give us 10 times 180. It's actually not going to be a bad multiplication problem because we have 10 times 180, so we just have to move a 0. So the sum of the interior angles is 1800 degrees, or 1800 degrees. How does that help now?
Now you can divide it by 12.
Why are we dividing by 12?
Find x.
To find x, how does that work? Why is that the case?
Because x times 12 equals 1800.
Okay, why?
Because there's 12 sides.
Okay.
Because of
I calculated all of the sides combined, or all of the angles combined.
Okay.
To try to find
Oh, I know what x is.
each angle.
Okay. Because we know that each angle is the same as each other, right?
Yeah.
And so all going to be 1/12 of the total, right?
Yeah.
Okay, so that's kind of our y there, okay? So we divide by 12 here. And what does each angle end up being, Bill?
150.
Okay, so x is 150 degrees
Chance it's wrong.
in this scenario. Questions on that?
Like my head's open.
Okay. So essentially what we did was we did this formula, n minus 2 times 180, but to find each interior angle, we just divided by n again when we were done. That's mathematically what happened there, right? Okay, we found the sum, which is the numerator in this, and we divided by the number of sides, which is also the number of angles. All right, I want to do the same thing for number 2. Name the polygon, this time it's not regular, and find x. So what type of polygon is this? It's a quadrilateral, right? Given by the 4 sides here. So it's a quadrilateral. How can we find x this time? Okay, Gage?
Well, you can do 4 minus 2 and then times 180.
Okay, 4 minus 2 times 180. And how's that going to help us on our trip?
Because it's going to tell you what all the sides combined are.
Okay, so all the angles inside add up to 360 degrees. So how does that help us?
What do you see?
You can't divide by 4
Oh, I got
because
this.
they're not all the same.
That's true. We can't divide by 4 because they're not all the same. It's not regular or equal angular.
You know that the bottom two
Okay, you know the bottom 2 are the same. What are the bottom 2?
90 degrees.
90 degrees.
Wait, is the capital or is okay? I'm confused myself.
Okay.
So we can subtract
So-
80.
Bill, what are you thinking?
With the remaining 100 degrees, you put it in a linear equation.
Not 100, but
180.
remaining 180, right? What do you mean by remaining 180? How did we arrive at remaining 180, Kaya?
Since both angles are 90 degrees, we don't need to solve for them. We need to solve for the other two.
Yeah.
And, since that's half of the sides already, then that means that we need to calculate for the other two. So that's all of this 180
Okay.
equals 6x plus 50 and 6x.
So it does end up being 6x plus 50, 6x plus 6x plus 10, or in the other order, equals 180, or flip that equation around. Where we were before that, though, that we didn't see, was this longer equation where we had 6x plus 50 plus 6x plus 10 plus 90 plus 90 equals 360, right? You have to add all four angles up to equal 360, the total sum of the interior angles, add all four angles up. Similar to what we did with triangles, right? It was just to 180 instead. This time the interior sum changed, so we're changing that here. But we subtract the 180, because 90 plus 90 is 180, and we end up with this equation in the purple. So we solve this by combining like terms, right? This linear equation, as Bill called it earlier.
Yeah.
And we get 12x plus 60 equals 180. Subtract the 60. We're left with 12x equals 120. So what is x? 10. Are we done?
No. You have to solve for the
Yeah, you have to solve those thingies.
Do we?
Yeah.
C.
Probably.
What's the instruction ask?
Oh,
Find
no,
X.
just find X.
Find x. Did we find x?
Yeah.
Okay.
Yeah, we don't care about those.
Could you plug it back in and make sure, oh, okay, yeah, this ends up being 110. This ends up being 70. Yeah, those all four add up to one or 360. We're good. Sure, you can double check. But we're done.
I got confused with the capital. So why?
Capital X.
Oh, I hate
Yeah, there's like a capital X on the top one.
Why would you point that out?
Oh, I guess it is.
No, don't.
It confused me.
All right, any question on these two? Yeah, Liam.
Well, we need to say it's convex, 'cause it's the name.
Yeah, here, no, we would not.
Don't do it. It was small enough.
All right, I want you to try example 3. Just find the value of x here. When you have it or have questions, raise your hand. So we talked about this one up here. Our setup is going to be adding all four interior angles up to equal what?
360.
360. Why 360? Because it's a quadrilateral, and that's the sum of the interior angles of a quadrilateral. So we add up, let's do the different color. 80 plus 70 plus x plus 2x equal to 360. So you end up getting 150 plus 3x equals 360, which gives us 3x is equal to 210. Divided by 3 on both sides, and we get x is 70. Questions on that?
I love that.
No.
So nice.
What is?
Oh, it's 7.
Algebra? Algebra's pretty neat.
I love how it's not a decimal or like
Just give me extra credit now, since I love it.
I love how they just.
I love the
I love that so much. I
forgot the
love
degree sign.
So technically, you don't need the degree sign here, and this is why. Great question. A great statement. The reason you don't need the degree sign here is because it's classified as x degrees. So if I put 70 in, is it 70 degrees already? Yeah, because the degree label's still there. So technically, we don't need it, but if we were asked to find the measure of angle T, we would need 70 degrees. Does that make sense?
Okay.
So technically, we don't need it, but I'll never count it wrong if you put it and you don't need it. That make sense?
So just always put it.
It's better safe than sorry to put it than not put it.
Well, then why did you put it?
Because you don't need to.
Because he's not safe.
So, don't.
He's
It's
not
less
safe.
work to not put it.
All right, number 4. I want you to try number 4. This is a thinker. How do we go about this one? This one's weird, right? We're given the end rather than the beginning. Okay, Kyle, what did you do?
So we know the total number of what all the angles equal.
Yep.
So the equation that we use to figure that out is n minus 2 times 180. So then if we just have that and equal the 1,000, whatever.
Yeah. So that's correct. Okay. So normally we have our n minus 2 times 180 equals the sum of interior angles, right? We've been knowing the sides, the number of sides n. we haven't known the sum. We've been finding that. Well, just like other algebra problems, we'll take the equation, we'll plug in what we know, in this case the sum is 1260, and we'll solve for what we don't, in this case n. And we turn it into an algebra problem. That's a very common thing that we do in both math and science with formulas. Sorry? Thank you. Is we will take an equation, take a formula, we'll plug in what we know, and we solve for what we don't.
Where's the flag?
It was falling, so I had to take it down for now. I'll have to put it back up. All right, so how we solve this one is then we would divide by 180. If you wanted to, you could distribute the 180 and go from there. I think it's easier to do it this way. So if n minus 2 is equal to 7, so then you add 2, and n is 9, giving it a, I should say, nonagon.
Wait, how did you get n minus 2 to 7?
Yep. So I got n minus 2 equals 7 because we divided by 180 because we are multiplying by 180. And then when we divide this by 180, we get 7.
Okay.
That make more sense?
Yes.
Okay. So if I really wanted to, I could distribute 180 and have 180n minus 360, add the 360, divide by 180 then, or I can do it this way and my number stays smaller, which I'm going to prefer. Either way would work, mathematically speaking. Questions on that one? All right, let's talk about exterior angles for a bit, okay? So let's say we have here a regular pentagon, okay? Regular pentagon, so 5-sided figure, convex, equilateral, equiangular. Each angle would be 108 degrees, so that way they can add up in total to 540 inside. We talked about with triangles that we could do an exterior angle, right? We said, hey, we can do this thing where we extend the line and we have this exterior angle over here, right? That sound familiar to us a little bit?
Yeah.
Okay. And we had this theorem, and it was that the exterior angles of a triangle added up to a certain number. Does anyone remember what number that was? Gage?
180.
Nope, not quite. Okay, it was 360 degrees, okay? They always ended up to 360 degrees. Let's figure out here, how could we figure out what this exterior angle would be, specifically this one right here? Aiden?
360 minus 180.
Not quite? Not quite? Max?
180 minus 108.
That's correct. 180 minus 108. Why is it 180 minus 108?
Because
Because
right
it's,
angle.
It's a straight line, right? These two angles form a linear pair of angles that form a line, okay? So it ends up being 72 degrees for that.
I just say it makes a right angle because
Okay.
it makes a right angle on both sides and just add those and it's 180.
But it doesn't make a right angle.
90 degrees.
Oh, well.
Right angle is 90 degrees.
Yeah.
Now, if we were to do this at each angle,
Makes a right angle line.
what would this one be?
72.
72 degrees. What would this one be?
72.
And I heard Gage say, well, why don't we just multiply by 5? That'd be the same thing, right? As adding 5 of them up. Because all of these here, since it's a regular polygon, would all just be 72 degrees. And what do we get if we do 72 added together 5 times, or 72 times 5?
Never mind.
Oh, genius.
You get 360 degrees
No, maybe, yeah.
for the sum of the exterior angles. Okay?
No, wait.
So it was like that for triangles. And was it like that just for equiangular triangles? Or was it like for any triangle?
Any triangle.
Okay, any triangle, okay. It's like that for this pentagon. I want you guys to try the hexagon here. So you get. What did we see for the hexagon here? What was each exterior angle in this one?
60.
Okay, it was 60 degrees. Okay, and so what would that make the total sum of the exterior angles?
360.
360 degrees, right? Okay. Have we talked about the scene from The Incredibles where Dash puts the attack on that? Coincidence? I think not. Okay. And once again, this is actually not a coincidence. Okay. We have this exterior angles theorem for polygons. The sum of the measures of the exterior angles of a convex polygon, not true for concave, but for convex polygons, as long as you have one angle on each vertex, it's always going to be 360 degrees. So no matter whether or not it's a regular polygon or not, how many sides it has, as long as it's convex, the exterior angles will add up to 360 every time. Pretty neat. So the interior angles get bigger and smaller depending on the number of sides, number of angles. The exterior angles always stays 360. So here, on this problem, we have a pentagon inside. Is this a regular pentagon?
No.
No, but it's a convex pentagon, isn't it? Okay, it's all pointing out, none of it's caving in.
Wow.
So this convex pentagon, what do we know the sum of the exterior angles has to be?
360.
360 because it's a convex polygon. So could we find y here by knowing that fact?
Yes.
Sure. Okay, who can tell me what my equation would be to find y? Anna? You're good. Putting you on the spot. Do you want to phone a friend?
Sure.
Hey, what friend do you want to phone? Okay, Bill.
Y equals 360 minus 40 minus 65 minus 60 minus 70.
Okay, that's one way to do it. How else could we do it? Gage?
I did 360. Y equals 360 divided by 5. No, not y. Another variable equals 360 divided by 5, and then 180 divided by that variable is a y.
I disagree, and I'll talk about why I disagree. Okay. The other way I was going to say we could do it is we could add all 5 of these up, which is essentially just the inverse of what Bill did. I'm saying y plus 40 plus 65 plus 60 plus 70 equals 360, because the sum of them will add up to 360. Bill just is like, well, I'm going to subtract them anyway, so I might as well just start by subtracting them. Okay. So, Aiden. What? The only other way I was talking about was saying y plus these numbers versus 360 minus the numbers. There would be a second, much longer way to do it. I'll talk about that in a moment as well, and I'll talk about Gage's idea as well. So here, if we take y and we subtract each of these, what do we get y to end up being? Okay, 125 degrees. Okay. Now, if we try Gage's idea there, and I love that you're putting forth that idea, even if it's not quite, end up working. Okay, so Gage said, I'm going to take 360 divided by 5 since there's 5 exterior angles. And that'll get me 172? Yeah, that makes sense. Okay, that'd be 72 degrees each. So if these were all the same, they'd all be 72 degrees. But are they the same? No, that's where it falls apart. Right there is where it falls apart. They're not the same, so that can't work. Yeah. So if you wanted to, you could figure out, well, how far each of these from that average, 72, and say, oh, this is 2 away, this is 12 away, this is 7 away, and this is 32 away. Add up all of those and add it to the 72 that'd be left for this one, and you'd end up getting it, because they all have to average out to 72 degrees still. But that'd be a lot extra work. Another way you could do it if you really wanted to is saying, hey, inside here, well, if this is 70 degrees, this is 110. If this is 60, this is 120. If this is 65, this is 115. Okay, I guess that's the one up here. This is 40, this is 140. And so you could say, oh, well, if the whole thing has to add up to 540, this angle over here has to be 55 degrees. And then say, well, 55 subtracted from 180 is 125. Would that be a lot more work? Sure, it's doable. But anyway, question on any of that, guys? All right. I want you guys to try number 6. I'm a mean guy. All right, let's start with this one up here. Anyone have any ideas for either X or Y? Okay. Jacob, what's your idea for X?
I was gonna do Y, but
Okay.
then can I do Y?
Sure.
So what I did is since
I took 67 and 75, and 67 on the inside would be 113. 75 on the inside would be 105. And since it's a hexagon, pentagon, it has to equal 540.
Yep.
And we know that the inside would be 90 up there.
Yep.
And since those two are equal, I just subtracted 113, 105, and 90 from 540.
Yep.
And then I just divided that by 2 since
Yep.
they're both equal. So
Yep.
I got y equals 161.
Okay, so you got each of these angles to be
161.
161.
Yeah, y equals 161.
I don't agree with that. I don't think y ends up being 161. I agree the way you're doing it would work, though. Okay.
That means 332 bigger.
Yeah, 300.
For if you add them all up and subtract 40.
That makes more sense. So these each then would be half of 232. So they each would be 116. I would agree with that number.
Oh, I just wrote it down.
So if those are each 116, what would that make y then?
64.
Yeah, the supplement of that 64 degrees. Is that the only way we could have found that? No, potentially an easier way would be by finding x first, right? Okay, how do we find x, Bill?
Well, yeah, I thought it was 90, so I was like, it has to be 90.
Yeah, 90 plus 90. So x is 90, right?
Yep.
Okay, that one was, of the two, I would say is easier, okay? So now that we know x is 90, Bill, what can we do to find y?
I did 360 minus 75 minus 67 minus 90.
Okay, so Bill said, hey, 360, if he subtracts the, that's the exterior sum, okay? If we subtract 75 an exterior angle, 67 another exterior angle, 90 the other exterior angle, that's going to give us the other two exterior angles. Well, if these two interior angles are the same, what do we know about their two exterior angles? They have to be the same, right? Because they're both supplements adding up to 180 with the same interior angle, okay? So that's going to equal really 2y in this scenario. So then you end up getting 128 equaling 2y divided by 2, and y is 64. Does it really matter which way you go about it? No, whichever one makes more sense to you, okay? I certainly have my preference on which one I think is easier. It makes more sense to me, but there's not a right or a wrong way, okay? Question on that. All right, last problem for today. The measure of one interior angle of a regular polygon is 108 degrees. Find the number of sides of the polygon. There are two ways to do this. I want you guys to go ahead and try this. What is one way we could go about this? And not just looking back earlier in the notes. There are two mathematical ways to go about it. What's one of the mathematical ways? Kaya?
36
Okay. Kaya's on to something. One of the ways involves the sum of the exterior angles. Okay, Gage?
Well, if you find the exterior angle of 108, that is 72.
Okay, and that's because we know it's going to add up to 180 with it, right? So if we subtract from 180, 108, we know the exterior angle is 72. And we have the luxury of knowing it's a regular polygon, so what's every exterior angle?
72.
72, okay, continue on, Gage.
And then, so you do that, so you get 360 divided by 72 equals 5.
And that's going to tell us, hey, there's 5 exterior angles.
Which means it's 5 sides.
And so that also means there's 5 interior angles and 5 sides.
Why did we do 5?
If we didn't do
Why not?
six.
And we do it 4 years.
Why did we do 5? Is that what you asked?
Oh, I thought,
Does that make more sense, Kai, or no?
I didn't know if you solved it. You just wrote it down, so I thought it was kind of the equation.
Oh, nope, that's just the answer. Now, what would be another way to do this? Seth?
You could Google it.
You could Google it. Okay. What would be another mathematical way to do this? Okay. Okay. How about I said earlier, back on our very first slide today, when we were finding each interior angle, we took n minus 2 times 180, the sum of interior angles, divided by n, right? We could set up that formula here. And so we could do the n minus 2 times 180 over n is equal to the each interior angle. Plug in what we know. Well, okay, we don't know n, but we do know each angle is 108. So from here, you'd solve. Well, you don't want an n in the denominator, so you multiply by n. N minus 2 times 180 is equal to 108n. Here, I would recommend distributing. You get 180n minus 360 is equal to 108n. Get all your n's together, either on the left or the right side. It really doesn't matter. If you get them on the left side, you'd have to move your 360 over. I'll get them on the right because of that. Negative 360 is equal to negative 72n. Do we end up really getting the same problem?
Yeah.
Because we're still dividing by 72, right? From 360. So either way, it's really kind of the same problem. Okay? So whichever way you want to think about this is perfectly okay. Okay? Now, hint, hint, wink, wink, nudge, nudge. Okay? You might want to know how to be able to do this one of these two ways mathematically, besides just looking back at your notes or Googling or PhotoMath. Okay? You might need to do that at some point. Just my opinion, though, in 2 cents.
No.
Okay? But what do I know? Okay? Any question on that, guys?
No, wait.